Okay, hello everyone, welcome back to another video of an average programmer. Today we will solve a LeetCode's daily challenge, which is a problem 2257, count unguarded cells in the grid. And the problem requires us to count all the cells in which the guards cannot see. And each guard can see in all four directions, up, down, left, and right. But what happens if there is a wall? If there is a wall, then the guard will not be able to look at all the cells that are next to that wall. Okay, so we will be using some sets to be able to get the wall coordinates, and also we will be using a set for saving all the cells that we already expanded with its direction. Okay, so for doing this, let's just say that we will have first an enum referring to all the directions in which we will be expanding. Okay, so every time that we are encountering a guard, we will expand, or we will see up, down, left, or right, or we can say that we can expand in all the directions. When we are starting our expansion, we will look at all the directions, but when I'm here, I don't want to look at all the directions too. I just want to be looking downwards. So that is why I'm also adding other cell directions. Okay, then we're going to be having an enum for our cells visibility. Okay, so in this case, all the red cells are the cells in which we are able to see, and all the green cells are the cells in which we do not have any visibility. Okay, so we will be having an enum for that. Okay, and let's first start with the declaration of my grid. So for this, I'm going to insert the function. This is the function that you might be getting. So sorry for deleting that, but here it is. Here is the function. Here are our parameters that we're going to be receiving. And we will be doing first a grid of m times n. And we will be filling our grid with a bad visibility. Why this? Because let's just say that we're not able to see anything, but every time that we are running our algorithm with each guard, we will be changing the visibility of each cell to a good visibility, obviously if it is possible. Then we will have our walls set. Why are we using a walls set? Because I want to see if the coordinate that I'm checking is part of the walls. And so doing that without a set will be some time consuming. So let's just say that I will have a set to check fast if my coordinate is a wall or not. Okay, then we will have another set for saving all the cells that we already expanded, and also with its direction. Okay, so that is good. Then I will be adding this other variable, which is going to be my result, all the non-visible cells, and I'm going to be returning that. So let me write that right here, non-visible cells. Okay, good. So let's start by filling our walls set. So for doing that, I'm just going to be using a for loop for each loop, and I will be adding the coordinate to my walls set. Okay. So then I'm going to be creating my expand function. So I'm just going to be creating this function. I will receive the I and j, and also I will be receiving the direction in which I will be expanding the cell. Okay, so what happens if I'm out of bounds? So if that happens, I'm just going to be stopping my expansion because there are no cells to see. So I'm just going to be stopping right there. Then I will parse the cell into a string. This is because I already that's because I already said that my walls set is going to be a string set. So so I'm just going to be creating the variable for that. And also I'm going to be creating the cell and direction string. Okay, so I'm just going to be concatenating the cell plus my cell direction. Okay, so what happens if I encounter a wall? Well, if that's the case, I'm just going to be stopping my algorithm. I don't want to be looking to all the cells that are next to my wall, so I'm just going to be stopping my algorithm. And also, what happens if I already checked that cell in that specific direction? For example, in this case, we can see that this cell was expanded in the left and also down. So I want to be able to avoid the same operation. So that's why I'm using dset. And then I'm going to be changing the cell value, obviously, just in case that the cell visibility is bad. I will be changing that to a good visibility because I'm able to see in that direction. And I'm just going to be adding my cell and direction to my set to say that I already expanded that cell in that direction. So I'm just going to be using now a switch function. So here is my switch function, and I'm going to be acting based on the cell direction. If I'm expanding the cell outwards, then I'm going to be expanding again the cell in that direction, and it's going to be happening the same for each direction. And what happens if I receive that I want to expand in all the directions? Then I will be in this case, which is the default case, and I'm going to be expanding in all directions. Okay, so that's good. And since I created my expand cell function, I'm just going to be applying that function to all the guards. So for each guard, I'm going to expand that cell in all directions. And once this is finished, I'm just going to be counting all the cells in which I have a bad visibility. Okay. I'm going to be iterating again over the cells, and I will count all the cells that have bad visibility and also the cells that are not in my walls set. And I'm going to be incrementing my variable every time that I'm encountering a cell with those attributes. And finally, I will be returning the non-visible cells. Okay, so oh, sorry, I think I inserted that in my function of expand cell. So let me put that out. It should be here. And I'm going to be returning my non-visible cells. Okay, so I think this should be the solution. I already submitted this, so let's see. Okay, so the two test cases are passing. So let's submit our solution. Okay, so the solution was accepted, and I hope it was useful for you. I'm going to leave also the code in the comments so you can check it out and analyze it on your own. So that's all, and see you in another video. Bye.